All right, so we're going to talk about 6.1, which is conic sections. Now, conic sections are different than functions. They're not always functions. In fact, there rarely are functions. Conic sections they get their name because if you take two cones and cut them with planes, you get different sections. For example, if we cut it across this way, what we get is this cross section here, and that's a circle. Or if we cut it this way, we end up with a cross section like this, which is an ellipse. Or we can cut it where we hit through both of these and we end up with what's called a hyperbola. Or lastly, if we just cut through part of one, we end up with a parabola. You have a much better picture of this in your book, so you can look at that. Conic sections have a general formula that we talked about in class. Ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And we talked about how a circle is when you have a and c equal to each other, but not 0. An ellipse is where you have a and c that are not equal to each other and the same sign. A parabola, one of those has to be 0, and a hyperbola, they're not 0, and they're different signs. So a and c are the ones that you look for to decide what kind of conic section it is. Now, we're not going to use this form very often. We may start here, but it doesn't really help us. We're going to have to complete the square on all of these so that we can figure out which kind it is and figure out different things about vertices and centers and radiuses and things like that. So make sure that you remember how to complete the square. We've gone over that in class several times, and you need to make sure you know how to do that. If you're having trouble with completing the square still, you need to come see me immediately. So the main conics covered in this section is a circle. So what is a circle? Well, you may say that you already knew what a circle was, but I bet we don't quite remember. A group, or in math terms, we call it a locus, of points in a plane that are equidistant from one point. So if you have a circle, they're all equidistant from this point. Now, this line out here is a circle. If you have a picture like this, that's not a circle. That's a circle with a whole bunch of stuff filled inside it. Okay, only the line on the outside is a circle. Now, a circle has a center. Here in the middle, that's the point that everything's equidistant from. And it has a measurement that tells you what that distance is, and that's called a radius. And you guys know all that. For our conics, we're going to use some generic formulas to figure things out. And for a circle, our generic formula is x minus h squared plus y minus k squared equals r squared. And that means the center is the point h comma k, and the radius is r units long. Okay, so this is our general formula. It's on your formula sheet. You need to know it. You need to recognize it. It's very important that you know that. So let's try an example. So if we want to find the center, the radius, the domain, and the range for, let's say, this equation here. We have x squared plus y squared minus 4x plus 6y minus 23 equals 0. Well, we know it's a circle because we've got our coefficient in front of the x squared and our coefficient in front of the y squared, that a and c, are equal to each other and they're not 0. So the first thing we need to do is get the x's and the y's grouped together. And the numbers on the other side. Okay, so we're going to have x squared minus 4x, and then plus y squared plus 6y equals 23. So we move that over there by adding it to both sides. Now, the next thing we need to do is complete the square. We're going to put the extras on the other side instead of on the end like we did before. Okay, so how do we complete the square? Remember, we divide the middle term by 2 and then square it. So 4 divided by 2 is 2, squared is 4. So we have plus 4. And then here we complete the square also. So 6 divided by 2 is 3. 3 squared is 9. Now, we added stuff here. So whatever you add to one side, you've got to add to the other side, or else you've changed the whole equation. So make sure you remember to add it to this other side here. Once you've completed the square, you can factor it and get it in working form. So remember, you designed it this way, x minus 2 squared. You designed it so that it would factor into squares. That's why it's called completing the square. So now we have it in our working form. So we know what? Well, we know that our center is h comma k. So we have h is 2 and k is negative 3, because remember it's y minus k. So our center is at 2, negative 3. And our radius is 6, because this is our r squared. So we find our center and radius. And then we'll be able to graph it and look at the domain and range. Now, you can find the domain and range without graphing it, but it's a lot easier if you can look at the picture. So we found our center. So now we want to graph it. So let's come over here, see if we can get some room. Now, it's going to be a lot easier to make these look right if you have graph paper for this section. This whole first few sections are going to want graph paper probably for this, because most of the time when you graph it, you have to be really careful or you won't have a nice enough scale to make it actually look like a circle. So we know our center is at 2, negative 3. So we go over here and we've got 2, negative 3. So there's our center. We also know the radius is 6. So that means that we're going to go 6 in every direction. So we go 1, 2, 3, 4, 5, 6 from the center. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and as you can see, because my scale is not great, it doesn't really look very much like a, let's see here, 1, 2, 3, 4, 5, 6. Yeah, it doesn't look very much like a circle because my scale's not real good. But if you have a nice even scale on graph paper, you should get it to look like a circle. And there it is. is you've got a radius of 6, and you know where your center is. Now let's try if we go the other direction. What if I tell you that the diameter of the circle has endpoints at -4, 1 and 4, -5? Well, if I want to know the equation for the circle from this information, then what I need, remember I need x minus, I need h, and I need k, so that's the center, is r squared. Well, let's think about a circle here. We know the diameter cuts all the way across it. So we know that the midpoint of the diameter is the center of the circle. So remember the midpoint formula, we just average the x's and then average the y's, and that gives us our center of 0, -2, because we took the midpoint of this segment connecting these two. So that means we've got an h of 0 and a k of -2. Now what else do we know about a diameter? Well, we want this value here, r, but the diameter is twice that. So if we find out how long this diameter is, how long this line segment is, and then take half of that, we'll know what r is. So we need our distance formula. So the diameter is, we use that distance formula. We have -4 minus 4 squared plus -5 minus 1 squared. So if we calculate that out, we have 8 squared is 64, 6 squared is 36. Add them together, you have the square root of 100, which is 10. So that means our r, our radius, is half of that, which is 5. So now we know we have x minus 0 squared plus y minus -2 squared equals 5 squared. And then we can just simplify. X squared plus y plus 2 squared equals 25. And here's the equation for the circle that has this information. That's all there is to it. Circles are the most basic conic. Everything's sort of measured from circles, so make sure you've got these down. Hopefully this is at least a little bit of a review from geometry stuff. So make sure you know this stuff. Make sure you've read the section in 6.1, and we'll go over it the next day in class.